Alright folks, we're back working on our mock EOC corrections. We're going to work on problems number 21 through 24 today. We're going to get another few of these problems in, so that way that we can do some review problems as we get closer to time for the actual EOC to make sure that we got some basic stuff down. Okay, so let's look at 21 first. So how many real zeros does h of t have? So what we're asking is when we replace h of t with 0, how many solutions to this equation are there? So our fundamental theorem for algebra, which we talked about in Unit 4, basically says that the highest degree, so we look at our highest exponent, is the number of solutions. So we either have, we've got 3 total solutions, right? They can be a mix of both real or non-real. And this non-real includes a bunch of things. It includes things like complex numbers. Remember those numbers that have I in them. It includes things like, let's just leave it with that right now. Okay, we'll come back to it. So real, we can have either 3 solutions, 2 solutions, 1 solution, or no real solutions. So for non-real, we need to figure out where we get non-real solutions from. So for complex numbers, this is saying we're taking the square root of like a negative number, right? So when we take the square root of a negative number, I just pulled 4 out of the hat because it's easy for us to do. The square root of 4 is going to be 2 or negative 2. And the square root of negative sign, negative 1, is I. So we have 2 solutions. So that says if we're going to have complex solutions, they're going to come in pairs. Which says that if we have 3 real solutions, it says 0 non-real solutions, which we can do. 2 real solutions says 1 non-real, which we can't do. 1 real says 2 non-real, which we can do. Or 0 of the real, which says 3 non-real, which we can't do. So we have either 3 or 1 as our options. So we can get rid of B and D because we know we have to either 3 real solutions, real by the way, or C, 1. So the question is, where do we go from there? Well, I'm going to use some of the space down here for this. We'll come back to this. We can factor this expression. We can factor a t out of the first 3. So when I factor a t out, I'm going to get t times 4t squared minus 2t plus 1 minus 10. So it looks like we're going to have to figure out how many solutions we can get from here. If we figure out how many solutions are in the inside, because our outside numbers be irregular numbers, we're going to get equals 0 still. So we can have 0 or 1 or negative 1 or whatever solution makes this equal to 0. So something times this minus, so we make t something, when we multiply by all this, we get positive 10. So that's going to give us at least 1 real solution, which says we still have either C or A. And when we think about this one, we need to factor this thing. So this thing factors something that multiplies to be positive 1, but subtracts to be negative 2, which is going to give us, and that 4t squared in the front. Oh, you know it's probably easier just using the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So this thing from our formula sheet. So what's going to tell us on here, remember from Unit 4 again, whether we have complex numbers or not, is the stuff underneath the radical sign. So I'm just going to use just that. So b squared minus 4ac. So b squared is negative 2 squared minus 4 times a times c. So that's going to be 4 minus 16, which is negative 12, which says we have a square root of a negative number, which says we are going to have complex answers, which says it can't be none of them, so it has to be one of them. So it has to be our last answer that we have not eliminated. Okay, and that's a long one, but fortunately we'll use this and some of the other ones we do in just a minute. Okay, 22, what are the possible rational solutions of this equation? So this is actually 8.3, which is called the rational root theorem. You will get there before you take the EOC. I expect all of you to score 100% when we get there. Until then, we're just going to circle B and say that we haven't gotten there yet. We haven't done 8.3. Okay, 22 is fast. 21 took some time. 22 is fast. Let's go to the back side. Completely factor this expression. So, we're getting some factoring stuff again. Well, we know all of them have 2xy, 2xy. So if we factor this out, we are going to get B. This thing, and then I looked up here at A. So I looked at A and said there's no way that 8x to the third plus y to the third squared is going to give us that. There's no way that can happen. And I said, well, what if I just try that? Let's just distribute it out and let's see what happens. 8x to the third times 8x to the third, 64x to the sixth times y to the third is plus 8x to the third, y to the third. Another one of those And then the last one of those is y to the third times y to the third, which is going to give us y to the sixth. So when we combine these like terms, we're going to have 64x to the sixth plus 16x to the third y to the third plus y to the sixth, which is that, which says it's not that one because at least a can go further. This is our original after we factor our GCF out, which our GCF is the same for all of these, so that's kind of frustrating. So then I said, there's no way that we can get one of these. Well, factoring, we're just going to say yes. It's always going to be possible. I was looking on the formula sheet. There's nothing that helps factoring with cubes. But there's a real short fact.
For right now, like we've eliminated B, we're going to get rid of A as well because we can always factor further. So at this point, it's like a 50-50 shot, right? So it's either C or D. And here's what I know. I know that if I multiplied all of these out for D, 4x squared plus 2xy plus y squared, multiply that by itself, I'm going to get a ton of terms. Just like when I multiplied 2 terms by itself and I got 3 terms total, if I multiply this thing by itself, 3 terms by itself, I'm going to get at least 4 terms total. And then I multiply the 4 terms by my 3 terms here, I'm going to get at least 6 terms total. So what I know is that unless I have a negative sign in here to start canceling some of these terms out, it's not going to work very well. So this one is going to give us a ton of terms. So when we square this section, we're going to get, just like 2 terms squared gives us 3 terms. When we square 3 terms, we're going to get 4 terms. When we square 2 terms, we're going to get 3 terms. So we have 3 terms times 4 terms, which is going to give us a minimum of 7 terms. We might have some combining some GCF, but there's no way we're getting back down to just 3 terms again, just these 3. So we're going to have to say, no, this is going to give us way too many things, and go with C. Okay, last one for the day, number 24. How many rational zeros does this function have? So here's the key word here is rational. So when we say zeros, again, we're going to replace this. 0 equals x squared plus 4 times x minus 4 times x squared minus 2x minus 5. So this is a lot better setup than the other one we had for number 20, what was that? 21. And the reason is because this is already factored. We know that to multiply to get to 0, we have to have 0 could equal any one of these parts. We call this a zero product rule. So we're going to set each of these parts equal to 0 and solve each of these individually. And we don't have to do it all the way, we just solve it a little bit. Okay, first one, we're going to subtract 4 on both sides. So we have negative 4 equals x squared, square root, which we know how to take the square root of negative 4. We just did that as an example. We're going to hit positive or negative 2 equals x. 2i, I'm sorry. So that's 2 imaginary ones. Well, when we think about real versus non-real, these are 2 answers in here that are not real. And for us to be a rational number, it has to be a real number. Remember, rational numbers are like 1/2 and like 2/3 and like 4 pi over 3 and things like that. So all of those have to be included over here. So we could say if we get 2 non-real, because they're complex, we can say, hey, we only have 3 real possible solutions at this point, which says we definitely don't have 5. Okay, let's add 4. So we get 4 equals x. That's real and rational because we can write 4 over 1, right? That's a fraction, so that gives us 1 real at least. Woohoo! So let's look at this last one. So this last one is still going to deal with that quadratic formula, that negative b plus or minus b squared minus 4ac all over 2a. So let's find the discriminant again and see if that tells us any information. B squared, negative 2 squared minus 4 times a is 1 times c is negative 5, so we get 4 plus 4 times 1 is 4 times 5 is 20. Negative times negative is a positive. We get the square root of 24, which when you think about that, is irrational. If you plug the square root of 24 in your calculator, it is a number that goes on and on and on without end. And let's see, it's between, let's see, 3 squared is 9, 4 squared is 16, 5 squared, so it's between 4 and 5. And it's probably much closer to 5 because the square 5 squared is 25. So that's 16 and 25. So we take the square root of each of those, we get 4, square root of this one, we get 5. So it's really, really close to 5, so it's probably like 4.9 something. But it goes on and on, it does not repeat, which is the definition of an irrational number,
which says that our answer, because we have 2 complex, which are non-real, we have 1 rational, so of the 3 that are remaining, we have 1 that's rational, and 2, because the square root of 24 is both a positive and negative answer, 2 that are irrational, that we only have A as our answer, and that's technically a level 3 problem, which is hard. There's a lot of thinking that goes on in there. You have to know the difference between real and non-real, rational and irrational. All right, folks, we will talk about these in just a second. Until then, hold on to them.